Hey guys, welcome back. This is the lesson that most of you have been waiting for. In the next series of lessons, we'll see how to set up a cluster in AWS. We have seen over and over in other courses where they would start with setting up the cluster right away, without providing enough knowledge about Hadoop architecture. We see students struggle at this stage since they don't fully understand the architecture and drop the technology altogether. It's like teaching a student to build a guitar first who's actually interested in playing a guitar. That is why we took a different approach. We want the learning experience as easy as possible for our students. And hence, we created a cluster and provided access to the cluster so students can use it for learning. Now that you fully understand the architecture and concepts involved in Hadoop, we think you are absolutely ready to set up a cluster. We will set up a Hadoop cluster on Amazon Web Services. In this lesson, we'll talk about what is Amazon Web Services. We will launch instances in AWS. In the next lesson, we'll download and install all the needed components to run Hadoop and do all the needed configuration to stand up a Hadoop cluster. In the third lesson, we will start all Hadoop services and finally validate our Hadoop installation. Sounds like a plan? Let's get started. What is AWS? Amazon Web Services, or AWS for short, is a collection of remote computing services that make up a cloud computing platform which is offered by Amazon. Here's the homepage for Amazon Web Services, and you can visit the homepage at aws.amazon.com. So let me log in. AWS offers a wide variety of software services to choose from. Let's say you want to stand up a Linux or Windows instances. You can do so in a matter of minutes using Elastic Cloud Compute, or EC2 for short. If you would like to store a large volume of data on the cluster, you can choose to use Simple Storage Service, or S3 for short. And let's say if you want to start a database like MySQL or Oracle, you can do so in a matter of minutes again with AWS under Relational Database Service, or RDS for short. If you would like to execute a MapReduce job on a pre-installed Hadoop framework across multiple computers, you can launch a MapReduce job using Elastic MapReduce, or EMR for short. With AWS or any cloud computing platform, you don't have to own private servers anymore. Launching hundreds of instances is at your fingertips. And most importantly, you can do so in a matter of minutes. AWS is not the only cloud computing platform. There are many other players in the market like Microsoft Azure, Google Cloud, Rackspace, etc. But AWS is a pioneer in this area. A lot of successful websites like Netflix, Reddit, Yelp, etc. are powered by AWS. Okay, take a look at this slide. We are going to stand up 3 Linux instances or servers, and we are going to install Cloudera CDH, short for Cloudera Distribution including Apache Hadoop, version 5.4 on them, which is the latest version of Cloudera Hadoop as of this recording. Here's our setup. Ideally, we would like to install name node and resource manager on different nodes. But in the interest of time and keeping things simple, we are going to install both name node and resource manager on the same node. Then we will install data nodes and node managers on the other 2 nodes. Finally, we will install secondary name node on node 2. We will refer node 1 as the master node and node 2 and node 3 as slave 1 and slave 2 respectively in this lesson. There are few ways to install a Hadoop cluster. We can use a tool named Cloudera Manager, which is offered by Cloudera, which will pretty much automate the deployment. Cloudera Manager has a good web interface which will pretty much walk you through the deployment. Cloudera Manager offers more of an autopilot deployment. Even the configuration of the cluster is done by Cloudera Manager. We can also choose to do a manual deployment in which we download individual modules like name node, data node, etc. from Cloudera, install and configure those services one by one. This will take more time and effort, but it is definitely worth the effort. Because doing a manual deployment, we can understand every single step, what we are doing, and also know the configuration details behind the scenes. Whereas if you choose to use Cloudera Manager to install, it will do most of the work for you, but you will not get to see what happens behind the scenes. So we will use the manual deployment approach where we will install and configure the cluster all by ourselves, step by step. Now we have a basic idea of what we would like to achieve. We'll do a manual deployment of CDH version 5.4 on 3 nodes. In our master node, we'll install name node and resource manager. On both slave 1 and slave 2, we'll install data nodes and node managers. And secondary name node will be installed and configured on slave 1. Okay, now the very first thing we would need is 3 Linux instances. So now we want to decide on which flavor of Linux we would like to use for our installation and what version of Java to install, etc. Let's look at the CDH5 requirements and supported versions page on Cloudera's website. In this page, Cloudera clearly lists all the OS requirements. As you can see, you can install and run CDH5 on Red Hat Linux, CentOS, and Ubuntu. We are going to use Ubuntu latest version 14.04, which is codenamed Trusty. Now, let's look at the supported JDK versions. Cloudera supports JDK 1.8, and again, we'll use the latest JDK 1.8 release. Okay, now we know we are going to use Ubuntu operating system, and for Java, we are going to use the latest release of JDK 1.8. And we'll install CDH5 5.4, which is the latest version of Hadoop from Cloudera as of this recording. As you can see, we'll be using the latest version of Cloudera Hadoop on the latest OS and Java. Latest stuff is always better. Now let's see how we can start 3 Ubuntu Linux instances on AWS. First, you need an account with AWS. Creating an account is free, although keep your credit card handy because you need a valid credit card to register. But you will only be charged for your usage. With new accounts, you will also get to run one free tier instance free for 12 months, which sounds great, and it is, but the problem with that is free tier instance comes only with little less than 1 GB of main memory, which is pretty low, and it is not ideal to run Hadoop on it, and that is the limitation. With AWS, you pay by the hour for your usage. Once you create an account with AWS, log in using the account. I'm logged into the AWS console right now, and this is the home page you will see. Since we would like to start Linux instances, we have to go into the EC2 service, which stands for Elastic Cloud Compute. So let's click on that. We have 3 instances running already. Now we are going to create 3 more instances. So let's click on Launch Instance. Here, the very first selection that we would have to do is to select the operating system. We know we are going to use the latest version of Ubuntu, which is Ubuntu 14.04. So let's select that. The next selection is very important. Here, we have to choose the instance type. This is a very important choice because based on what you select here, will incur charges accordingly. The very first option is the free tier. It offers 1 GB of main memory, which is very low. And it says here free tier eligible. It does not mean that you can run many free tier instances for free. It says very clearly here, for the first 12 months following your AWS sign up date, you get up to 750 hours of micro instances each month. When your free usage tier expires, or if your usage exceeds the free tier restrictions, you pay standard pay-as-you-go service rates. If you do the math, 750 hours is roughly running one instance 24/7 for a month. To check out the pricing of instances on different tiers, visit AWS EC2 pricing sheet. Amazon is good about bringing down the prices from time to time. Here you will see all instances are priced by the hour. The instance we're going to choose for the demo is T2 Medium. It offers 2 virtual processors and 4 GB of RAM, which is ideal for us, and it costs $0.052 per hour. So I'm selecting T2 Medium here, and I'm clicking Next Configure Instance Details. We need 3 instances, so let's enter 3 here. The rest of the options we don't have to change. Click on Next to configure storage. Since this is a demo cluster, I'm going to leave it as 8 GB. But if you're planning to do some serious analysis with Hadoop with big data sets, choose the amount of storage accordingly. Now again, storage costs money. You can look at the pricing for storage in the pricing sheet here. Storage on AWS is powered by a service called Elastic Block Store, or EBS for short. Here you can see the pricing. Usually, magnetic storage is cheaper when compared to solid-state drives, or SSD for short. I'm going to leave 8 GB and SSD and move on to the next page. I'm not going to tag the instances here, so let's click on Next. Here we'll configure the security groups. Here you can define what kind of protocol, IP ranges, and port ranges that you would like to allow to access your nodes on AWS. Production nodes will have very limited access, and you can also specify specific IP ranges and port ranges to define which IPs can access your nodes on which protocol and on which port. Very powerful stuff. Since this is a demo, I'm going to make the nodes visible to anyone, but still you need access or keys to connect to the node. So for the type, I'm going to make all traffic. For protocol, it will be default to all. Port range is 0 to pretty much everything. And source, anywhere, which means anyone from anywhere can connect to our instances. Finally, you can give a name to the security group. I'm leaving the name as is. Let's click on Review and Launch. Now let's go ahead and review the information. We are selecting Ubuntu Server 14.04, and then the instance type is T2 Medium, which comes with 2 CPUs and 4 GB of memory. And then our security group is wide open, which is okay for a demo cluster. But if you're going to run a more permanent cluster, you would need tight controls here. Let's click on storage. Make sure storage looks good. We have 8 GB for storage here, and it is okay for a demo cluster. Let's go ahead and click Launch. Now we need keys to connect to the cluster. Select the key pair you would like to use to log into the cluster. If you don't have one or doing it for the very first time, just select Create a new key pair here and give a name to the key pair and click on Download Key Pair. And a .pem file will be downloaded. Keep that file in a very safe place, as this is your private key and you would need it to connect to your instances. Since I already have a key pair, I'm going to choose an existing key pair and select the key pair right here, which I have named it as HIRW. So I'm going to select, I acknowledge that I have access to the private key, which is the PEM file, and I'm going to say Launch Instances. As you can see here, the instances are now launching. Let's go to the EC2 home screen. Okay, so let's click on Running Instances. As you can see, our 3 instances are coming up here. The instance state is pending. It will just take a couple of minutes for the instances to be completely available and running. There you go. Now our 3 instances are fully running. So let's go ahead and name these instances as Master, Slave 1, and Slave 2. Okay, I'm going to name this Master. Hit Save. I'm going to name this Slave 1. Hit Save. I'm going to name this Slave 2. Perfect. Now we need to get the address of these instances to connect to them. These instances are publicly accessible from the internet by using the public DNS. And internal to the AWS network, they can be accessed using the private DNS. We will be using public DNS to connect to the instances from our laptop and private DNS in our configuration files to configure Hadoop. So let's take a note of both. You can use this file here as a template, which will guide you through this whole cluster setup. You can find this file in the resources section. All you have to do is, once the instances are started, simply replace the public and private DNS on this file with the public and private DNS of your instances. Let me show you. The first in the list you see here is the public DNS for the master. And then you have the public DNS for the slave 1. And then you have the public DNS for slave 2. Let's get the public DNS of the master. Copy this. The public DNS for the new master is EC2 52.3.178.66. We are going to use this new public DNS name to replace the existing public DNS for the master. So copy the public DNS for the master from the file and put it right here. And then hit Replace All. So now we have changed 5 occurrences on this file. So the public DNS for the master in this file is now pointing to our newly created instance. Let's go ahead and do the same for slave 1 and slave 2 as well. So let's go to the AWS screen, copy public DNS for slave 1, go back to our file. Now take the slave 1's old public DNS from the file. So find that and replace with the new public DNS for slave 1. Hit Replace. Just 1 occurrence is changed. Now let's do the same thing for slave 2. So I'm going to first copy slave 2 here. put it right here, and then go back to EC2, copy slave 2's public DNS, go back to the file, and paste it on the replace with field. Click replace all. Again, 1 occurrences were replaced. Now let's do the same thing for private DNS as well for master, slave 1 and slave 2. You will see in the later lessons that the private DNS for the master, slave 1 and slave 2 will be used in the configuration files. So do not skip this step. Okay. Copy the internal DNS of the master first. Now go back to the EC2 screen, click on master, copy the private DNS, and use this to replace your private DNS of the master in the file. Hit replace all. 10 occurrences were replaced, and that is why it is very important to do this step. So now copy slave 1, put that, go back to our EC2, copy the private DNS of slave 1, and use that to replace the existing private DNS for slave 1. Hit replace all, 4 occurrences. Now let's do the same for slave 2. Go ahead, slave 2, copy private DNS, and do a replace all. 3 occurrences were replaced. Perfect. Now we have transformed this entire file specific to our newly created instances. So all the configuration information in this file is now pointing to our newly created instances, which will make our life much easier during configuration. Now it's time to connect to our instances. I'm using Windows, so I'm going to use PuTTY to connect to our instance. Remember, we selected or created a key pair that we will use when we launch the instances, right? We need the .pem file to log into the cluster. If you are using PuTTY, you need to create a .ppk file from the .pem file. To do that, you need a small utility program called PuTTygen. So simply Google PuTTygen, go to the download page, and look for PuTTygen right here, and download this small exe file. And once the download is complete, open PuTTygen. So I've already downloaded the file. So here's the PuTTygen. Click conversions and say import key. Now here you have to choose the PEM file that you received. So here's the PEM file for HIRW. So I'm choosing this file. Now from this PEM file, you can get the private key and the public key. For this setup, we need the private key. So hit save private key, say yes to this, and give a name to the PPK file, and hit save. Now we will use this .ppk file with our PuTTY to log in to our cluster. Now we have the private key. Let's open PuTTY. Let's first try to connect to the master. So let's copy the public DNS of the master from our file, put it in host, give a name to this session. I'm going to name it master, and go to SSH, click on auth, and select the .ppk file which we just created. Select that. Now hit save. Now let's try to connect to master. Click on open. There you go. For this screen, hit S. Now we are presented with a login screen. Now we are attempting to connect to a newly created master instance. The key that we selected during the instance setup will automatically be assigned to the user login named Ubuntu. So for login name, use Ubuntu. So type in Ubuntu. There you go. We are now authenticated and we have connected to our newly created master instance in just a matter of minutes. Awesome, isn't it? Let's now configure PuTTY for slave 1 and slave 2 as well. I'm going to do the same steps that I did for master. So let's open up PuTTY. Copy the public DNS for slave 1. Paste it here. Give slave 1. Go to SSH. Click on auth. And select HIRWPPK. Go back to the session, save it. Now let's go ahead and do the same for slave 2. All right. Change the host name. Give slave 2. Go to auth. Select the private key. Go back to session, hit save. There you go. Now we have master, slave 1, and slave 2, all configured for PuTTY. So once my PuTTY is configured, I usually use a tool called mRemoteNG. The convenience with this tool is I can open multiple terminal sessions and I can see all the terminal sessions in a tab-like interface. So it is easier to switch between sessions. So let's go ahead and click on master. Type in Ubuntu. There you go. I'm connected to master. Now let's do the same for slave 1. We are connecting to slave 1 for the very first time, so you'll see this alert. Click on S and say Ubuntu again. There we go. We are connected to slave 1. Now let's connect to slave 2. Hit yes. Type in Ubuntu. There you go. Now we have connected to all 3 newly created instances. And this is how you connect to instances if you're using Windows. But if you're trying to access the instances from Linux, check out the course setup lesson for Linux from chapter 1 for instructions. When you use the SSH command to connect as shown in the video, use Ubuntu as the username and the public DNS of your instances in place for the IP address shown on the video. Let's continue to follow the instructions in the setup template file. Now what we are going to do is we are going to copy the contents of the .pym file that you got from AWS, not the .ppk file which we just created, but the .pym file which we got from AWS. Copy those contents into id_rsa file. The reason we do this is because during the cluster setup, we will copy files between nodes and we need the contents of the .pym file, which is the private key, on id_rsa file. So when a node is trying to connect to one another, it will be able to authenticate with the private key seamlessly. So now let's go ahead and do this on every single node. The first thing we will do is switch to the .ssh directory and open the id_rsa file. So let's do that. I'm going to copy these 2 commands together. Let's first go to master, copy this. The id_rsa file is now opened. Go to the insert mode. Now open the pym file for HIRW. Copy the contents of this file. This is your private key. Paste it on the id_rsa file and save it with WQ. Once that is done, we have to change the permission of the id_rsa file, making Ubuntu as the owner, and restrict the file permissions as well. So let's go ahead and do that as well. Perfect, that is done. Now let's do the same thing on slave 1 and slave 2. Go to insert mode, copy the contents, paste it, save it, change the permissions. Let's move on to slave 2. Open the id_rsa file, go to insert mode, copy the private key, paste it, save it. Let's change the permissions now. That is it. Now our all 3 nodes will be able to authenticate against each other since we have our private key on the id_rsa file. Now we are able to launch 3 instances in AWS and we are able to connect to them as well. In the next lesson, let's install all the needed components to configure and start a Hadoop cluster. See you in the next lesson.